Hey, my students, let's talk about projectiles and more importantly, analyzing different parts of their paths. So no matter what, the thing you should always kind of start off doing is looking at the X and Y parts during the motion. And that's what we're going to focus on a lot in the class and in this little video. So first let's talk about level ground. That means that when you fire something, it starts and ends at the same height. So delta Y is 0. When looking at this, there are a couple things you need to think about. The maximum range, or the farthest it can go with that velocity, is when the angle is 45 degrees. If you're above 45 degrees, it goes higher in the air, but not as far. And if you go lower than 45 degrees, it doesn't go as far as well. So we learned that complementary angles have the exact same range. So something you shoot at 60 degrees and 30 degrees will go the exact same distance if it's on level ground. If it's on level ground, it's not going to be the same, obviously. They're going to have unequal times, however. The higher the angle, the more y velocity, the longer it's going to take. So I put a dot here at the max height. At the max height, the y velocity is 0, but the x velocity is going to be something unique. So at the beginning point, the x velocity and the y velocities are at some values. So the x velocity starts off at the original x velocity because it does not accelerate. So to simplify it, the x velocity stays constant through the air. You can see here that at any 2 points directly across, the x velocities are still the same, but the y velocities, one's positive, one's negative. So now we're going to talk about horizontal shootings and not level ground. So let's say we have something right there on the edge, and we shoot it horizontally. Horizontally means the initial velocity is all in the x, which means there's no initial y velocity. The acceleration in the x is always 0. The acceleration of y is going to be negative 10 because gravity's pulling it down. So there's our path. So if you increase the x velocity at first, it will change how far it lands, but it won't change the time. We learned that in class. So now we're going to kind of look at different parts here. Again, in the beginning, the initial velocity is only in the x. The y velocity is 0. So just everybody's going to have a little arrow. But at 1 second in, the x velocity is still vx. But the y velocity is now negative 10. It went from 0 to negative 10. 2 seconds in, the x velocity is still the original velocity because it hasn't changed. But the y velocity is now another negative 10, which is negative 20. And you can see my vector triangles I drew. So in other words, the y displacement is getting more negative. The y velocity is increasing by negative 10 each second. The x velocity is still the original velocity because the x velocity doesn't change. But the overall velocity is going up because you're going from 0 and just an x value to an x value in 10, x value in 20. The overall, which is the hypotenuse, keeps getting bigger and bigger and bigger. So now let's look at something at a massive arc. I don't know why I cut off the top here. I wasn't showing that on my phone. That's not good. But at the initial point, the x velocity is v naught cosine theta. The y velocity is v sine theta. At any point, the x velocity is still v naught cosine theta. Now at the maximum height, the x velocity is still v naught cosine theta, but the y velocity is now 0. And each second, the y velocity is changing by negative 10. So at any point there, you're going to see a couple things. In the top half, before it goes back to its starting point, the y velocity is getting lower till the top, and then it comes down, it's getting faster. So at the exact same height, we know from before, the x velocity is v naught cosine theta, the y velocity is negative v naught sine theta. Delta y is 0. So once you're at the top, the velocities are minimized because the y velocity is 0, the x velocity is v naught cosine theta. But like it's, for example, 4 seconds in, the x velocity is still v naught cosine theta. The y velocity is v naught sine theta minus 40 because it changed by negative 40. So if the angle goes up, the x velocity goes down, the y velocity goes